look at the role of the brain and the actual areas in the brain that are involved in the production of language. And we have two very distinct areas that are involved in the production of language, or the reception of language for that matter, in the brain itself. And first of all, one of the ways that we have discovered some of these things is actually looking at impairment. And I've mentioned this to you before, is that oftentimes a completely healthy brain remains hidden to us until something actually happens to impair it. And then we get information about the area of the brain that's impaired and its connection to aspects of functioning. So with language, the general term we use is aphasia. And essentially, aphasia is an impairment in language that results from damage to any of several different actual cortical areas. And you begin to get an appreciation for just how much of the brain is involved in language when you begin to see what areas are affected. Brain, let me write this down here for a second, how much the brain is actually involved in language. Because we depend on thought, we depend on memory, we depend on the production of the words. So we have the muscular aspects of it in our mouth, and the management of breath that goes into it. And so we have two very different areas that is involved in language itself. Now, the first one is an area that was discovered by Paul Broca, and we refer to it, as the name suggests, as the Broca area, and it's the left frontal lobe, and an area in the left frontal lobe, left frontal. And what he discovered essentially is that this particular area has to do with the motor cortex, and so this is the production of speech that becomes an issue when this part of the frontal lobe is affected. And I could have you listen to a person who has a Broca's aphasia, and what you would find is that they can speak. It doesn't mean they can't, but it seemingly can't seem to find the right words to actually say what they mean. So their language is fairly devoid of anything meaningful. Now, the second area is Wernicke's area, and this is a German by the name of Karl Wernicke. And he discovered the left temporal lobe. So we've got the left frontal lobe, and then we've got the left temporal lobe, Wernicke's. And as just like above, we have Broca's aphasia, we have Wernicke's aphasia. And what he found is that with damage to the left temporal lobe, and let me just write that down just so that you don't miss it, left temporal lobe. The person could speak basically only meaningless words. So they don't have trouble speaking, but what they speak is meaningless. And so when you listen to somebody with Wernicke's aphasia, they seem to be in search of the meaning of particular words. As your book has an example of that, where the person's shown a picture of two boys stealing cookies from behind a woman's back, and the person's response seems to be, like I said, kind of in search of meaning. They can't seem to come up with the word at all. So in Broca's aphasia, they have trouble producing speech. In Wernicke's aphasia, they can produce speech, but it's meaningless. And those are the key distinctions between the language processing that we have found, essentially. The big point to remember here is that essentially in processing language, the brain operates by dividing functions. So we've got basically something that you might call a division of labor in the brain to be able to manage various aspects of language. And so Wernicke's area and Broca's area are a good example of that. Speaking, perceiving, thinking, remembering are all really basic sub-functions of what we refer to as language and how it actually operates. And it also means that essentially if one area is affected, the other one may not. And so a lot of the testing that we do tries to plumb the depths of this issue so that we can help the person adapt if they have some specific areas of difficulty. So division of labor, which includes speaking, perceiving, thinking, and remembering. And if you notice in the sequencing of these, I have to perceive something. Speaking should actually come later when it comes right down to it, because I have to perceive, I have to think about it essentially, and then I also have to store it into memory somewhere to be able to pull it back out and then speak it, thinking, and I'll just put memory. And each of these are key to understand, and like I said before, each of these areas are shown in this diagram, which is from your book, where hearing words, auditory cortex, is right in this area, which is right in the temporal cortex and close to our actual hearing. Speaking is closer to the frontal cortex, where we're making decisions about the words we use and how we use them themselves. So, so that gives you a little bit of an idea of the brain and how it operates in language itself.